Hi, in the last lecture we talked about recursion, which is an important way of thinking about problems in computer science. And we looked at some fairly toy examples. I want to show you a few examples today that seem maybe a little more practical. As a review, a recursive method is one that calls itself. So somewhere in the body of the method is a call to the same name that the method is. And the recursive method needs two parts. One is the base case, which is basically where the recursion stops. And it's basically some sort of specific parameter value that doesn't cause another call to the method. It has a specific answer. And then a reduction step, which is where the recursion happens, but it also progresses the answer towards the base case. And usually accumulate some kind of answer as it goes. So, we looked at some kind of like adding up numbers and this Fibonacci type sequence. But those are, again, things you could do pretty easily with a loop. But sometimes some problems map pretty naturally to this recursive concept. And so, one example might be looking through a folder structure on a computer. And if you're looking at your files, there's sort of two main things, right? There's actual files, like a Java file, and there are folders. So the source folder, the package folder, and so on. And a folder can consist of even additional folders and files. And so there's this sort of this branching structure that's not just like an array. So you can't just loop over it and just get values. You have to think about how to go down each part, each folder, and sort of examine what's going on in all those branches. So that seems fairly complicated. Luckily, this file class that we've used before to read files actually does things like it has additional capabilities. And so let me grab a docs page here. So this is the overview of the file class. And again, there's a certain skill in looking at this stuff where you don't want to get bogged down in what a Microsoft Windows UNC path is and these separator things, and you sort of have to learn how to skim stuff. And you can build it in different ways. And then there's a bunch of different methods here. For example, you can delete things, which seems a little dangerous. I would suggest not playing around with that in case you do something wrong. This path stuff, which is again the string that represents the sequence of folders to get to where you are, is important. And there's a lot of things for manipulating the path. You can ask whether something is a directory or a file. There are also hidden files. You can find some time when it was modified, how long the thing is. So there's a lot of different. You can, and if it is a folder, you can list all the files in it. You can make directories and so on. Anyway, there's a lot of stuff that file does that we haven't actually had to explore. So you can test if it's a file, and if the thing is not a file, it's basically a folder. So we can sort of exploit that to start doing things and use programs to do certain things on our folders. So we can check if some file F is a file, and if it's not, we can list the files, and it produces an array of file objects, and we can test each of those to see if they're files or folders. Right. So we can do. Let's write some methods. So let's just count the number of files in a folder, and that doesn't mean just like if there's a folder we just count the files in it. We also if there's a folder inside that folder, we want to go into that folder and count how many files are there. So we want to count all the files contained inside some structure. And so the base case here is that something is a file, because once it's a file, we can just count it. We say that has a value of 1, right? And the reduction step is to break apart the folders that we can see and go into them and count up how many things are in there. And again, it's not necessarily just files in there. There could be other folders. So here's an example of, here's a folder, CS10 1410 test, And in it, there's 2 files, but there's also a folder. And in that folder, there's 1 file, but there's also 2 other folders. And inside, like folder 3 here, there's 2 files. Inside folder 2, there's 3 files. And so you can imagine, you know, it gets confusing quickly, right? You can't just say, count up the things in this folder. You have to sort of count up the things plus the things that are also included in other folders. And you can't predict in advance what the structure looks like. You can't say, oh, go into the 1 folder that's in here and count up its files, because there's 2 folders in this one, right? So if you already knew what it looked like, you wouldn't have to count it. So you want to make sure that you're being general here. All right, so so let's do this thing. Count the number of files in a folder. Let's write some code for that. So I'm going to write a method, and this is going to be a static method. So public static, and it's going to be count files, and I'm going to pass in a file to start. So at the very beginning, we're going to get some file based on some some path to a folder of some kind. And we're going to say how many files are in here. And when we're counting something, what's the return type going to be? Well, it's going to be an int, right? So I want a number coming out that says how many things were counted. So how are we going to do this? Well, the easy case, let's say let's call this thing. So int num files equals count files. And I'm going to make a new file object right in place here. And where is that folder? Well, I know where it is. It's in my home directory, users detail. So CS1410 test. So I'm going to say, tell me how many files are, do I have enough things here? Oops. Tell me how many files are contained in this folder. And again, we're talking about this folder here, right? We don't know about what a file is, so I have to, quick fix it and import file. Did I import it? No, I did not. Import file. Okay. So I am passing in this folder, which is something that a file type can handle, into here. And so how am I going to do this? Well, first I'm going to say, well, what if this thing is really just a file? You know, it's something.txt, right? I can ask if that's the case, if f is file. And again, I'm not doing is true or something like that. This is going to return true or false. And if it is true, I'm going to return 1 because it's 1 file. Right? So let's say I passed in this thing here exactly a path to a particular file. It would pass in that file here and say, is it a file? Yes, and return 1. So yes, how many files are in a file? One is. So we're good here. Else, let's put that on up here. Else, what do we want? Well, we want to know if it's not a file, say it must be a folder at this point, right? So if it's not a file, it's a folder. So let's get all the files from that folder. Files equals f dot, what is the actual thing? List files or something like that? List files. List files. So this breaks the folder into all the files that are inside it and stores them in this array. And for file on files, so I'm looping over the files and storing them one at a time in file here. And what do I want to do? I want to add up some kind of total. So I need a variable here to count up how many files we're going to find. Total files equals 0. And here I'm going to add, oops, ITN. I'm going to say total files, add whatever we're going to count up for file. And at the end of this, I'm going to return total files. So there's two choices here. One is that we pass in an actual file, like a text file, and then we say there's one of them. The other one would be passing something that is a folder, kind of like this thing is going to be here, this CS14 test. We list all the things that are in that folder, and in our example here, the three things that would be listed would be folder 1, b.text, a.text. And we add up the count of each of those things. So when it's a.text, let's say the a.text is the first thing in the files, that we call ourselves with a.text and it returns 1. So this evaluates to 1 and we add 1 to total files. Then we loop and now it's b.text and we send b.text to here and we get a 1 back. The next one is going to be folder 1. So folder 1 comes in here. It's not this, and instead we break folder 1 into all its parts, right? So all of a sudden now we've recursed, and folder 1 has these things here. We loop over those things and add them up and return its total, and that's what gets added into total files. So let's at least try this thing out. I'm not sure I've actually done all the parts that we need. Total count is num files. When we run this, total count is 8. Okay, let's see if that's true. I don't even know if that's true. We're counting files. 1, 2, 3, 4, 5, 6, 7, 8. So 8 files. And it found them all. Now notice, again, this would be kind of hard to structure as a loop, right? Because you have to say, we're descending all these layers, you can't just loop over one of these things. There are ways to do it as a loop. You have to learn later. We'll learn about stack and queues, and you can basically add information onto these things that you loop over later and remove. But so these can all be structured as loops, but they require some more complicated data structures. This is a pretty natural way of doing this. It says, if it's a file, return 1. If it's not a file, return the total of all the things we find inside it. That's the only thought process you have to do. But somehow you have to, believe that this thing is going to be worming through all these things and finding them. Let's try to print out some stuff and see if we can see this a little more closely. Let's see. There must be some to string. I guess we could print out. Let's print out the file if we're in here. Let's see. So let's look at, we just print F, right? And so it should print out like what it's looking at this point. Okay, so it looks at the folder. It looks at the text file. It looks at the text file. It looks at that folder 1. Inside folder 1, it looks at folder 2. Where am I? Inside folder 1, it first looks at folder 2. In folder 2, it looks at e.text, d.text, and then this f file name.text. I had that long because I was thinking about doing some searching for long names as well. And then it's done with the folder 2 stuff. It get the totals for that, and then it looks at folder 3. In folder 3, it looks at F and G, and then when it gets the total for that, it comes back and looks at C.text. So you can kind of see how it's looking at all these different things. It would be hard for us to, kind of plan that out, right? You have to sort of say, count this one thing, count everything else. and that's what the recursion does for you. It's a hard, to me, when I write this kind of code, I have to kind of look at a few examples, get in this recursive mindset, and then just kind of go for it, to be honest, right? You're like, return the thing I know, otherwise return everything else. And that's sort of the general model of these things. Looking at this stuff makes me think it'd be nice to print out the contents of all these folders in some sort of organized way. So let's write a method to, I'm going to skip the size of the largest file. Let's print out the files in a nice format. Like, you can't really tell here. There's a lot of extra stuff here. We don't want to print out all this stuff. So let's look at print out for the folder contents. I'm going to write another method. This is going to just print stuff out, so it's a void method. Print contents on some file F again. Okay, so how are we going to do this? If it's a file, let's print out the, let's always print out the name. So I'm going to print out f dot get name. Okay, get name just prints out the b dot text part, so that's kind of nice. If it is a file, what do we need to do? Well, we're done. We don't need to print. We've already printed out the name. Maybe I'm just going to move this. I think we can. Let's do it this way. If it's a file, we're going to print out the name. Else, if it's not a file, it must be a folder, right? So let's print out the folder name also. And then we're going to print out all the things inside it. List files. Okay, so first of all, one thing here. Up here, I got all the files, and then I looped over the files. Here, I'm just saying generate in place all the array of files and loop over them. All right, so I'm not having that temporary all files variable in there. I'm just looping over it directly. So we print the name of the folder, and then I'm going to print everything that's inside it. So I'm going to print the contents of the file I find. All right. Notice I had to break it apart first, right? If I just said print contents of F, then it would just sort of print the same thing over and over again. But I have to make a progress step towards the final solution, which is I'm printing out the folder, and then I'm printing out all the things in the folder. Some of those are going to be files, and some of those are going to be other folders. Let's see what happens if I call this. So what I call this print contents. I'm going to steal this path here. So print contents of this folder. Okay, and I'm going to get rid of the prints from here so we don't kind of get too much stuff going on there. All right. So print the contents. Well, okay, we got the count, and then here's the folder. Here's the stuff that's inside the folder. And here's the stuff that's inside folder 1. And here's the stuff that's inside folder 2. Actually, I think that's backwards, folder 2. Anyway, it's a little hard to read this, right? There's all just this list of stuff. And it'd be nice to show the structure of this as well. And so we can do indenting to show what belongs inside one part. All right, so if it's indented, it's inside, like B would be indented to show it's part of this CS1410 test. And I think that will help. So to do that, I want to show you, it's sort of this is going to be this interesting thing. We're going to have this string indent. That's part of the recursive call. And so when I start off, I have to actually start off with an empty string. In other words, when we first start off, we're not indented anything. Oh, I put this in the wrong place. I was like, okay, that's the count files. String indent. So here, when we print something, we're going to always print the indent in front of it. All right, and right now it's an empty string, so it doesn't do anything. And here I'm going to do the indent. And what happens when I want to call this again? Well, I want to add to the indent. So I'm going to have indent, and I'm going to add a couple spaces to it. Let's add 2 spaces every time. So when I recurse, when I call this from a lower folder, it takes the old indent and adds 2 spaces to it, and then it starts printing out stuff indented as well. So let's run this and see what happens. Okay, so this kind of shows a little more clearly, right? We have 1410. In there we have B, A, and folder 1. Inside folder 1 we have folder 2 and folder 3 and C, all the things that are indented at the same level. And inside folder 2 we have E, D, and F. And inside folder 3 we have F and G. Now why does this work? This actually, requires a little more description. So the first time in, we're passing in the empty string, and the CS1410 test is not a file, so it's a folder, so we print it out with an empty string indent. And then we call print contents with this indent plus 2 spaces. So when we come back, when we recurse for the first time, we have that b.text, and indent is 2 spaces, and it is a file, so we print out 2 spaces plus b. We loop again, and it's still the empty string plus 2 spaces for, what's the next one? A. So A gets printed out with 2 spaces, and this. The next one is a folder, as we print out the folder with 2 spaces. And then the contents of its folder we print out with the 2 spaces plus 2 more spaces, 4 spaces. And so we get these additional indents. Now when we're done looping over all this stuff, we're done with this method, indent goes back, and it's the old value of indent that's used, right? This doesn't change indent. It just means that the new indent that we're using for that particular call has 2 more spaces. When we're done with that method, it goes back, and indent hasn't changed on the original level. So that's why we can do stuff like have here, we add to the indent for those things, but when it's done with that loop, come back, and the old indent's the same as it used to be, right? It didn't change because it's passed by, it's a new string being built as when we do the plus sign on it. So this indent and this indent and this indent are all the same. These get indents plus 2, and then this gets this indent plus 2 more spaces when it does it. But you can have this thing that sort of grows and shrinks. The indent grows as we go down the recursion, and then shrinks as we pop back out of the recursion when we're done with that level of recursion. And so notice this thing is the thing that we're using to break apart and test. This thing is just something that we're accumulating to help us as we work on our nicely formatted printout of structure here. You'll see this kind of stuff if you're like on a terminal somewhere, like a Linux machine, or secure shelling into a server somewhere, and you try to print stuff out, like look at folders through a terminal, you can get format that looks like this. So it's pretty common. But kind of magical, again, I hate to use the word magic because it's not magic. It's all very deterministic and it's explainable. But in a very concise amount of code, we get this thing that has this sort of very nice effect, and it would be, again, quite difficult to write that in a single loop and somehow track sort of which indent you're working on and stuff like that. So anytime there's sort of this branching thing, you can go into files and folders or multiple folders. Recursion is a great way to think about these things. And again, in CS14 in 2420, you'll be using these a lot because these kind of structures come up a lot in more complicated algorithms. All right, enough of that. Probably you should take time to try to type it out and ponder this, and it's worth exploring for sure, and seeing if you can get your brain to accept how this is done. Okay, bye.